Homework number 7. In this video, we'll be covering the following topics. Let's start with the first one. In this problem, the question asks for the lengths of four sides of a quadrilateral and their consecutive integers. It also tells us that the perimeter is 86 feet. They want us to find the value of just the longest of the four sides. When solving integer equations, we need to choose which type of terms we're going to use. In this example, it states that they are consecutive integers. So that means the first one is n, the second one is n plus 1, the third one is n plus 2, and the fourth one is n plus 3. So now that we have the names of the four sides, let's use them to find the perimeter. Since it states that we have a four-sided quadrilateral and not a particular type like a rectangle or a square, then we simply know that if we add all four of these sides together, that the perimeter would be the sum of all of them. And if the perimeter is 86, then the sum of all four sides would be 86. We can simplify this expression to 4n plus 6 equals 86. We can subtract 6 from both sides, then we could divide both sides by 4. This tells us that the value of n is 20, but we want to find the length of the longest side. So 20 plus 3 gives us a side length of 23. Let's try another one. This example has similar language, but this time it says that the sides are consecutive even integers. So that means we would skip count by 2's. So this is how we would define the four sides. Again, the perimeter is the sum of all four sides. So n plus n plus 2 plus n plus 4 plus n plus 6 would equal 52. Again, when we simplify, we get 4n plus 12. And when we use our properties of equality, subtract 12 from both sides, divide both sides by 4, we get a value of n is 10. The longest side would be 10 plus 6, or 16. Let's take a look at the next level. In this example, we have a rectangle, and the perimeter is 52. So a rectangle has a perimeter formula of twice the length plus twice the width. So if the perimeter is 52, I can erase and replace this letter P. Now let's get some more information. It says the length is an odd integer, and the width is 3 times the next consecutive odd integer. So the length is an integer we don't know. We can call it n, or we can continue to call it L. Doesn't matter, but it's a number we don't know that just happens to be odd. If the width is 3 times the next consecutive odd integer, then we write 3 times this way. And the next consecutive odd integer after this would be L plus 2. So now we can fill these items right here that we've translated into their correct positions in the formula. So the perimeter is 52, the length we don't know, but we have two widths that are 3 times L plus 2. So I'm going to distribute here and get 52 equals 2L plus 2 times 3L plus 6. Then I'm going to distribute this too. 52 is 2L plus 6L plus 12. So 52 is equal to 8L's plus 12. Subtract 12 from both sides. And we would get 40. Divide both sides by 8, and now we know that the length is 5. So the question is asking us to find both the length and the width. So if the length is 5, now I can enter that value into the width formula. And the width formula is 3 times that length plus 2. or 3 times 7, which is 21. The next example looks like this. When an integer is subtracted from 3 times the next consecutive integer, the difference is 23. So we are using this pattern, consecutive integers plus 1. So it looks like we have 2. When an integer is subtracted, that's this, is being subtracted from, so that means we're going to take away this integer from something. And what is that something? 3 times the next consecutive integer. And that difference will be 23. So 3n plus 3 minus n equals 23, or 2n plus 3 equals 23, or 2n equals 20, which makes n equal to 10. They want us to find the value of the lesser integer, and that's this one. So the answer would be 10. The wording on this next problem can be a little tricky, so make sure you're taking good notes. This says Lavon is older than Mariana, so we're going to put them in this order. Their ages are consecutive even integers, so that makes Mariana n, or x, and that makes Lavon n plus 2. Find Lavon's age if the sum of Lavon's age, so we're going to add Lavon's age and 5 times Mariana's age, and she's n. So now we have our translation. That makes 6n plus 2, or 6n equals 60. That means n is equal to 10. So Mariana is 10, but they want to know Lavon's age, so that would be 10 plus 2. Lavon is 12. The third topic is fractional linear equations. I'm going to solve this using the new strategy of using the multiplication property of equality to clear all of these denominators first. 8 and 24 have a common multiple of 24. So I'm going to multiply every single term, both of these on the right-hand side, by 24. When I multiply this second value here, I need to be careful, because I am multiplying the whole fraction. So even though these 24s will reduce, this minus sign is subtracting the entire numerator. So I need to put that x plus 7 inside parentheses. Now, when I go to combine like terms, first I have to distribute this negative, giving me negative 27 minus x minus 7. Now, when I combine these terms, I'm going to get negative 34 minus x equals 24x plus 216. I'm going to add x to both sides, and then I'm going to subtract 216 from both sides. And that will give me negative 250. When I divide both sides by 25, I'm going to get negative 10. Let's take a look at one more. This time, my denominators are 5 and 3, and their least common multiple is 15. Now don't forget, on this left side here, you're multiplying the entire fraction. So if that numerator has an expression, right, not just a single term, but multiple terms, you'll need to use parentheses. So I'm going to reduce here by first dividing, and then I'll do the multiplying. So 3 times this quantity, and then 5 times this quantity. And on the right-hand side, I just get 30x plus 105. After I distribute, it will simplify to this. Then I'm going to combine like terms of my variables and constants. After I simplify the left side, I can start using a property of equality to get my variables together. I'm going to subtract 11x from both sides. Then I'm going to subtract 105 from both sides, giving me negative 152. And then when I divide both sides by 19, I'm going to get negative 8. Let's take a look at the next topic, linear equations with fractions level 3. This topic is the same as the previous, but we need to be careful. I see lots of denominators here, but not all of them are necessary right now, unless I choose to distribute first. I can either clear this fraction first, or I can distribute and then choose to clear the fractions. Why don't we try distributing first so we don't make any errors? We're going to get negative 20x minus plus 1 minus 9 equals negative 5x plus 3/2. So not too bad. I mean, I can clear that fraction or I don't have to. It's really up to you. But if I choose to, I would multiply everybody by 2. In doing so, I would get 16x minus 40x plus 2 minus 18 equals negative 10x plus 3. Then I would combine like terms of variables and constants. Then I'm going to add 24x to both sides. Then I'm going to subtract 3 from both sides. Then I'm going to divide by my coefficient. And when I do that, I'm going to receive a fraction answer. I'm going to leave it that way. The directions did say to leave it in simplest form. It did not say to convert to a decimal and round. It said leave it in simplest form. You can either use the division key on your keyboard, or you can use the Desmos virtual keyboard, which does show you the ability to make a fraction by typing the division sign like that. And now you can submit. Again, when you're trying to solve for x, if you have lots of fractions, you can choose to distribute first before you clear the denominators. This would give us a positive 2/3 x minus 5 plus 4/3 x equals negative 10x. I'm going to choose 3 as my common multiple to rename my equation. 2x minus 15 plus 4x equals negative 30x. Combine like terms. Subtract 6x from both sides. And then when I divide by negative 36, I'm going to write this in the most simplest form possible. So I know that each of these can be divided by 3. So I'm going to write it this way over here. And that is a 15, so that would be positive 5 over 12. 2 negatives make a positive, so 5/12. The last 2 lessons involve equations that have absolute value bars. Absolute value represents a number's distance from 0. So if I'm telling you that the absolute value of this expression is 45 units from 0, then I can be located at either positive 45 or it can be located at negative 45. I call this doing the splits. So I'm going to take this one equation and I'm going to use it twice. Once with the expression equal to the negative value of the distance, and once with the expression equal to the positive value. Notice when I split, these absolute value bars go away because I have taken those 2 absolute values already. So once I write the positive and negative version of this answer, the absolute value bars go away. The expression inside the absolute value bars should remain the same. C minus 20, C minus 20. I solved this problem twice by adding 20 to both sides, and I get my 2 solutions. When typing your solutions in, you can add an additional solution by pressing this plus sign. And now you can show both possible solutions for C. Let's try another one. Again, the absolute value is 40 units from 0. That means I can be located at positive 40 or negative 40. Once I split this equation into 2, the absolute value bars disappear. Keep the expression exactly the same, b minus 24. I'm going to add 24 to both sides and get my 2 solutions. The last section has multi-step equations inside the absolute value bars. You solve it exactly the same. Remember, the absolute value can be both positive and negative. And once you split it into 2 equations, the absolute value bars will disappear. 15 plus 3b, 15 plus 3b remains the same. Subtract 15 from both sides. Divide both sides by 3. So we've got -6 or -4.